Let's have a look at question 2A part 3. So we have got some information here about New Zealand children. And the previous information that we'd had, so just as a note down here, the previous information we had was about youths, and where we had a sample size n of 10 and a probability of one child having breakfast of 0.499. Now we're looking at the proportion for children. Okay, so that's what I've got in the second part here, is looking at the children being a binomial distribution. And we're told the proportion who eat breakfast daily is estimated to be 85%, which if I turn that into a decimal would be 0.85. So the question asks to find, the health worker talks about that the variation in how many youths that eat breakfast was much greater than the variation for children. So it's talking about variation, and that's why I have down here the formulas with the standard deviation, because our standard deviation, or variance, you could do the variance, but our standard deviation is a measure of the spread. It's a measure of how variable the data is. So that formula there is one that I got straight off your formula sheets, so you need to make sure you know where to find it. The other little thing to note is when it talks about and uses the little pi value, that just means p, the probability. Okay, pi is the Greek letter p, and so in this case we're not using it like we would for the area of a circle formula. Okay, right, so we need to calculate both of these standard deviations now for the youth and the child. So I'm going to say the square root 10 times the probability of 0.499 times 1 minus 0.499. And for the child, I'm going to do the square root of 10 times 0.85 times 1 minus 0.85. So I'm going to calculate both of these and see which of these is larger. So I'm going to just grab my calculator here, clear that. Right, so I want to do the square root, and I'm also going to put an extra set of brackets around everything underneath that square root, because I want to make sure that it takes the square root of all of that and all of that. So I'm going to add those brackets in. So the square root of 10 times 0.499 times bracket 1 minus 0.499, close brackets, and that gives me a standard deviation of 1.58. I'm just going to do 2 decimal places, 1.58. Okay, now I'm going to do the other one. So let me just, we are going to do, so where am I, square root of 10 times 0.85 times 1 minus 0.85, which is, I didn't like something there. I'll try that again. Square root of 10 times 0.85 times 1 minus 0.85 gives me 1.13, rounding that to 2 decimal places, 1.13. Okay, so those are my standard deviations, and what I can do now is I can look at this one and say, well, this one is larger. Okay, so that tells me the variation in the youth is larger than the variation in the child. Okay, so I'm going to make that little note that the standard deviation of the youth is more than the standard deviation of the child. And I can write that mathematically like this, or I could write that in a sentence. That would be fine. And then what we want to say is we need to comment on whether their observations can be justified. Okay, so they actually need to make a comment on it. So they observed that the variation in youth was much greater than the variation in the children. So that's our question here, is when I look at these, well, we know that the variation in the youth is bigger than the variation in the child. And so now we need to make a comment whether we agree or disagree with this. And so we want to say yes, the variation in the youth is larger or greater than the variation in children. Okay.